Okay, for lesson 4, we're going to be looking at the derivative sum rule and multi-ordered derivatives. Now, all this sounds a little crazy. It's really not too complicated. Just to start out with the derivative sum rule, this says that if you have a derivative, if you want to take the derivative of a sum of multiple terms, like um, x squared plus x cubed. Let me just change something. Okay, x squared plus x cubed, and you want to find the derivative of this d by dx. This is equivalent to taking the derivative of each of the terms, like this, and adding that up. Now, this will make it a lot easier to do derivatives of questions like this, because we don't have to take this crazy thing and plug it into our formula. All we have to do is break it up into this section and this section. So the derivative of x squared plus x cubed is simply 2x plus 3x squared. And to do it with another example, let's try x plus x. Let's try 2x to the fourth plus 2. Let's combine some concepts here. So if we do the derivative of this question, of this sum of terms, we can split it up into each part and take the derivative of each of these. So let's the derivative of x is 1, and if you want to look at the sum rule, we can look at it like this. This is x to the 1, and if we bring the 1 down, then this goes to 1, and then becomes x to the 0 power, and anything to the 0 power is 1, so it's just 1 times 1. So our derivative there is just 1, plus 4 times 2 is 8, and then x to the fourth goes to x cubed, and finally, with any constant, this goes to 0. If you remember, the graph is always going to be, the slope is always going to be 0, so the derivative, that's just 0. And so we have is 8x cubed plus 1. Now, when we talk about multi-ordered derivatives, what we're saying is we keep taking derivatives of something over and over. So if we had x cubed, the first derivative, sorry, so if this is our f of x, then our first derivative, we'll put that mark on there, is going to be 3, or we can put a plus 1 on here, and this just goes away, because, or I don't want to cross it out there, but when it comes down here, it goes to plus 0, and then this goes to 3x squared. But then a multi-order derivative says that this is a first order. Let's go to second order derivative. We have 2 marks there. It's the second derivative. So then the 0 is done. We can bring this down 6x. The third derivative is 6, because this just goes away, the x goes to 1 like we saw over here. And then finally, the fourth derivative is 0. And from here on, we're going to keep getting 0, 0, 0, 0 over and over, so this is where it finishes. But if you see something like this, multi-ordered derivatives, second-order derivatives, don't let it give you a hard time. It just means you're doing more than one derivative. So just keep doing derivatives over and over until you get to however far you need to go. But one of the things that's useful since we have time is talking about where this comes into play. You'll see this in physics. Where it becomes useful is if we have a function called s of t is something dot dot dot. If we have s of t, let's pick something. Let's say it's x plus 1. S of t, usually this s means it's saying where the point is on a graph. This is our position. If you plug in, actually, sorry, this shouldn't be x. This should be t plus 1. You give t a time, and you plug it in here, and this gives you your position. So we can actually make this t squared to make it a little more complex. We plug in our t. We plug in 3, for example, and then we get 10 as the point where it's going to be. Basically, this is the position. So if you're driving a car and this function said how far you were along the road, then you put in your time, how long you've been driving, and this would give you where you were from the beginning, how far you were from the beginning. But if we were doing the derivative of this is v of t, meaning your velocity. So if our velocity is 2t, this is telling us how fast we're going if you plug in a time. And then if you do the derivative again, we get our acceleration. So our acceleration is 2, meaning in this function I gave you, we're going faster and faster and faster, twice as fast at every instant. Or our speed is accelerating by this constant amount. So hopefully that makes sense. Don't worry about this yet too much, but that's probably how you're going to see it realistically, as a pretty common way of using derivatives right off the bat to help you solve problems. So join me in the next video where we will be getting into a little bit more of this stuff, the position, velocity, and acceleration. Alright, thanks for watching, and I will see you in the next video.